everybody. So this is a video for lesson 5 of topic 3 of module 1 for algebra 2, which is looking at analyzing polynomial functions. And we're going to be learning about something called average rate of change. And to understand that, we're going to review the slope formula. So the slope formula you remember from algebra 1, you may remember, is y2 minus y1 over x2 minus x1. It's the change in y's divided by the change in x's. So y's on top, x's on bottom. And you need to remember that the 2 basically signifies that y2 and x2 come from the same point, and x1 and y1 come from the same point. So you have two tables here, and you can pick any 2 points you want to do the slope formula. So I'm going to go ahead and do the first one, and I can pick any 2 points. You can pick the negative 152 with the 10 and the negative 62 with the 4. It literally doesn't matter which 2 points you use of this, okay? So let's say I'll use the first one and the second one. I mean, might as well. I can call this one x1, y1, and x2, y2. So plugging it in, I would have negative 2 minus 13 and 0 minus negative 1. That's going to give me negative 15 over positive 1, because 0 minus negative 1 is really 0 plus 1. And there's my slope. Go ahead and pause it and try the second one. Pick any 2 points and find the slope of the line in this table. So I chose the points 8, 12 and 16, 18, but you could have picked any of those 2 points, and I got 18 minus 12 divided by 16 minus 8 is equal to 6 divided by 8, which is 3/4. We're going to do the getting started. This is a very short lesson, so we're going to do as much of it as we can. So here's the situation. The polynomial function p of x models the profits of Zorzanza, a video game company, from its original business plan through its first few years in business. Okay, so let's pay attention to our axes here in this word problem. Our x-axis is time in months. Our y-axis is our profit in dollars. Okay, so the profit is changing over time in a variety of ways. So this is not a linear function, we can see. You may recognize this as a cubic function. Goes up and down and then back up. All right, so we're going to try to interpret this graph based off of some different events in the company's history. And we are not going to have any numbers to work with here, are we? Okay, there's no numbers here. There's no scale. There's nothing. All right, so the first event here is the chief executive officer anxiously meets with her accountant. The highly anticipated, let's just go through all of them and then we'll think about where they go, okay? B is the highly anticipated game Zephyr Zenith II is released. The company opens its doors to business for the first time. The company reaches its first short-term sales goal just as the holiday shopping season ends. The company breaks even. The member of the board of directors gets in a heated members of the board of directors get in a heated debate over the next move the company should make. The company fires its game design team after 2 game releases, Leisurely Sunday Drive and Restful Resolution. Delight many parents, but sell poorly. Is this supposed to be like the opposite of Grand Theft Auto? Leisurely Sunday drive and peaceful resolution. That's hilarious. And finally, a large conglomerate buys the company. Okay. So we want to look for points of positive profit, negative profit, but also when are they earning money, like it's increasing, or they're not earning money while it's decreasing. We want to look for those types of things. So we'll go back over them and identify these now. But you can pause it and try to think about where you think they would be, and then we'll go over it. All right, so let's start with the first one, A. The chief executive officer anxiously meets with their accountant. So this has got to be a point where they're not making as much money. Things are starting to turn around in a bad way. So essentially, you want to look at when profits are starting to decrease. And so I would put it on the downslope here, okay? And I'm going to explain my reasoning by just doing some bullet points here. Profits are decreasing. They're starting to go down. Okay. B, the highly anticipated game is released. Okay. That means profits are going to be going up. There's going to be an increase somewhere. So I would say like somewhere on the increasing area. Okay. So profits are increasing. I mean, they may be in the negative at that point, but they're going up, right? For C, the company opens its doors for the business for the first time. So that's going to be in like point where it's at 0 months. And we can see that because of the y-axis. So I'm going to say there. Okay, so I'm going to say when x equals 0, it's the start of the business. Something like that. The company reaches its first short-term sales goal just as the holiday shopping ends. We're definitely going to look at the top of the little hill there. Yay, they reach a goal after the holiday shopping ends, but then like after holiday shopping ends, they go back down. They're decreasing. Okay, so I would say it's the relative maximum. Which is before it starts to get bad again, right? The company breaks even. So breaking even means they're not making money, they're not losing money, the profit is 0. And so what you're going to look for there are the x-intercepts. What letter was it? I'm assuming E. Yeah, okay. So anywhere that you have an x-intercept, there's multiple options. You can do here, here, here. Anywhere there's an x-intercept would make sense for that. F, the members of the board of directors get in a heated debate. So things are not good. They need to come up with a plan, and hopefully they'll turn things around. I'm going to say down here because things are bad. It's really bad, but maybe they're going to fix it and it's going to turn around. To some degree, these are subjective. Some of these, like the break-even point, there's no other option than the x-intercepts, but some of them are a little subjective. So we could say for that one, it's kind of like at a low point. It's at a point where the company is losing money. Okay, the company fires its game design team after 2 game releases. Oh, yes. All right, so things were not going well. I mean, you want to see that they were not selling very good at all. Let's say that's about, I don't know, things were not going well around here. All right, we'll put that as G. All right, it's not going well. They're losing money. Okay, so they are losing money. Not losing. Losing at this point. All right, the large conglomerate buys the company. Well, then I would put that kind of at the end of the life cycle of right? Their profits are going to go way up if they just got sold. And then that's kind of it, right? So it's kind of at the end. Profits are up. Okay, so recognizing situation and tying it to a specific point in the graph is the skill here. So let's think about the question number 2 that says, do you think this cubic function is an appropriate model for this scenario? You can go both ways. If you're going to say yes, you could say it goes up and down, profits go up and down, right? But if you want to say no, you want to pay attention to the end behavior. The end behavior of the function is going to go down, 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 down in negative time, right? Before the company even existed, which makes no sense. And we know, even though the profits are rising, are they going to rise forever? Unlikely. So there's some mathematical things that are happening here that don't really tie into the real situation, but a lot of it does. So your answer could be both ways. All right, we're going to move on to activity 1 now, interpreting graphs of polynomial models. So this is similar, but notice we have numbers now. Okay, so it's the cubic function p of x, which models Zorzan's total profits over the first 5 years of business. So this is similar, but not exactly the same graph, because before we were dealing with months, and now we're dealing with years. Let's look at the graph. Let's pay attention. So we have years now. 1 year, 2 years, 3 years, 4 years, 5 years, but also notice we have half years in between. And for profits, we are in thousands of dollars. So that 200 does not mean they made a profit of $200. It means they made a profit of $200,000. But by saying our units are in thousands of dollars, we're saving some time by not having to write all the zeros. All right. So each line looks to be about $100,000 in profit. All right, so let's see. Use the graph to estimate when Zorzanza achieved each profit and explain how you determined your estimate. So our first is $800,000. So we look at the 800,000. Remember, this is $800,000. Follow the graph over, and we're going to estimate when this is. So we can see that this is 4.5 years. This is 5 years. So it's just a little bit past 4.5 years, I would estimate. Maybe about 4.6 years. Or if you want to convert that to months, maybe it's like 4 years and 7 months, right? Because 6 months is half a year, right? All right, and then 200,000. You just do the same thing, but you'll notice that it happens more than once. In fact, it happens 3 times. Here, about half a year in. here about a year, 1.3 years, here about 4.4. I'm just estimating, picking decimals that are kind of in the ballpark. So we'll say at approximately half a year, maybe 1.4 years, and once again at about 4.3 years. Okay, C, a profit that's greater than 200,000. So greater than 200,000, you want to look above that line that we just drew. So between these two and this whole section is all the parts of the graph that are greater than 200, than that line at 200,000. So that would be maybe between a half a year and 1.4 years. So it's between 0.5 and 1.4 years. And then after, what is that, 4.3 years about. So then the next one says the company loses money. And we're talking about like a negative profit here. So think negative. And when you think negative, you're thinking below the x-axis when the y's are negative. So I'm seeing here, here, those sections. Let me see if I can highlight them a little better. Notice I'm not going back in negative time here. That doesn't really make sense. So like kind of between 0 and a quarter of a year, I guess that would be, because the next line would be half. So I'm saying between, so this is like 0, this is like a quarter of a year because this is half. And then here is about maybe 1.75 to about 4.1. It's a little hard to say, maybe 4.2. Okay, so between 0 and 0.2 years and 1.75 and 4.2 years. Okay, so the company makes a profit. So profit is when we're looking above at the positives. So we're looking at the look above the x-axis. Okay, I'm gonna erase my blue highlighting here in this orange line so we can just focus on all of it. So maybe I'll use yellow. Okay, so we're gonna go, this section here is profit and this is profit. So when you're looking at they're making a profit or they're losing money, you're looking above the x-axis or below the x-axis. We're not looking at increasing or decreasing, although that's important, but that's not what they're asking. So that would be between year 0.2 and I'll just use the numbers I used before, 1.75, between, and year, well, not between, we'll say above or after year 1, no, that's a 4.2. Right? That's this portion right here. So interpreting when the profit is and when things are happening, we're basically doing the same thing we did in the getting started, except we're now attaching numbers to it, right? Okay. So let's look at this discussion about the end behavior. in number 2. So Abby says the end behavior is incorrect. As profit increases, profit approaches infinity. That doesn't make sense that the profits are increasing before the company even opens. Okay. The end behavior is correct. The function is a cubic and positive a value. That means the x value approaches infinity. And the y as the y value as the x value approaches infinity, y approaches infinity. As x approaches negative infinity, y also approaches negative infinity. So they're talking about the end behavior. They're saying it goes like this. I'm backwards. Hold on, I'll do it the other way. It's gonna go like this. If it's a cubic function with a positive leading coefficient. So who's correct? Well, the answer is they're both correct. Ariella is correct mathematically. Abby is correct in the context of the problem situation. So you do need to pay attention to both. So Costas makes this statement about Zoranza's profit. Explain the error in Costas' reasoning. Zoranza makes a profit after 3.5 years because the graph is increasing. Let's go ahead and take a look at what happens at 3.5 years. Okay, so 3.5 years is here. Well, is that a profit? They're still in the negative. It's not a profit. It's increasing. It's not a profit. It's not a profit until they break even and go beyond that. So the confusion is they're confusing increasing with a positive profit. Okay, it's increasing, but it's still in the negative, and that's the error. All right, let's go ahead and take a look at activity 2, and this is where you're going to get the important formula of the average rate of change. The average rate of change of a function is the ratio of the change in the dependent variable to the change in the independent variable over a specific interval. The formula for the average rate of change is f of b minus f of a divided by b minus a for the interval a to b. So if this looks familiar, it's basically the slope formula, but for something that's not a line. We don't call it a slope formula because polynomial functions don't have slope, only lines do. But it's essentially the same thing. We're using function notation here. Okay, f of b and b are basically saying when I plug in b, I get f of b. So they're a point. And then a and f of a, if I plug in a, I get f of a. And you've got the subtraction, you got the division. If you just think of this as the slope formula, you'll be fine. Okay. So let's take a look at this example. So you can determine the average rate of change of Zoranza's profit for the time interval 3.25 to 4.25. So this is an interval between this x and this x. So that's here and here, right? Okay, so we need to know what those points are. So this is the point 3.25 comma, that looks to be about negative 600 on the y. And this point is the point negative, or 4.25 comma 0. They broke even. So this thing, you can call it as A, and this is f of A. It's the output that goes with that A. And this one is B, and then this is f of B. This is similar but different notation to x1, y1, and x2, y2, like for the slope formula, okay? So you can see where they're plugging things in. We've got 3.25 is right here, that's an x. 4.25 is the other x, it's right there. See the a and the b. And then we've got f of a, which is for f of 4.25, which is going to be 0. You're going to see that gets filled in right there. And then f of a, which is f of 3.25, is negative 600. You can see it gets filled in there. Okay, so this is really right here. This is 0 minus negative 600. And then they did 4.25 minus 3.25, and they subtracted that to get 1. 0 minus negative 600 is 0 plus 600 is just 600 over 1. So the average rate of change is 600. But let's interpret what this number means. If you were to connect these 2 points with a line, get my line tool here. The slope of that line would be positive 600. 600 what, right? You gotta remember this is in thousands of dollars over a period of years. So this rate is really $600,000 a year. So it's telling us the average rate of change in this time period is $600,000 in a year. But it's a curve, because maybe it was a little slow at first, but then it started to go faster and faster, right? And so it's not a consistent speed. If it was, you'd see a straight line. That's why we call it an average rate of change. Okay, it's like the average speed of what's happening. If we average it all out, some of it's slower, some of it's faster. It averages out about $600,000 in that year. Okay. Explain why the average rate of change is $600,000 per year, not $600 per year. Because if you looked at the units, it was in thousands of dollars a year. Explain why the average rate of change is positive over this interval. Because it was increasing. It's going up. And what does the average rate of change represent in this situation? It's the average profit over that time period. Okay. Let's just do one more example of the average rate of change. We've got determine the average rate of change of Zerzan's profits for the time interval of 1, 3. Okay, so essentially, using their notation, we need to do f of 3 minus f of 1 divided by 3 minus 1. Now, what is f of 3 and what is f of 1? We got to look at the graph. So let's go back and look at the graph. I'm going to delete a bunch of stuff so we can see what's going on. Okay, f of 3. So 3 is right here. We're going to follow it down, and that appears to be 3 comma negative 600. We used that one before. F of 1 is right here. That is like positive 300. So what I see is this is going to be a decrease. I already know my number is going to be negative, right? Okay, so let's go back and fill it in. So we had negative 600 minus 300 over 3 minus 1. So we plugged in the 300, the negative 600. Gives us negative 900 over 2, which is negative 450. But let's translate it into the units. This is a negative $450,000, or we could drop the negative and then just call it a loss. It's a loss of $450,000 per year. Okay. All right, I'm going to leave the rest of this assignment for you to fill out, and then you can do the workbook quiz.